Yes, Ravi Kumar, do you want to ask something? You have raised your hand.
Voice is not clear. Voice is not clear.
Your voice is not clear. Maybe you can type in the chat box. I hope people will be keep on joining. Myself, Sandhya. I'm a PMRF research scholar from IIT Kharagpur. So, for your NPTEL session on payment materials, every Monday evening from 6 to 8 o'clock, you will be having a live session. I will be discussing what we are going to do in this 2 hours of session as we move forward. I see there are around 14 participants are there, and these participants are from wide variety of domains. Let me take from basics to the advanced, and we will see how we are going to utilize these 2 hours in every week. As this is the first class of our interactive session, um, we'll be first understanding what is your requirements and needs. Still, we'll be discussing few numericals today also. I think it's around 6 8. I'll share my screen and we'll start the class around 6:10 because this is the first day I'll be giving this 10 minutes. Maybe from next week we can start exactly by 6 o'clock. And meanwhile, if you want to ask anything, you can type your messages in the chat box. And at the end, you can also ask your doubts. As far as this 2 hours live session is concerned, last week you have started this course. So you could have finished 1 week of all the lectures, like 5 lectures on the soil related content. You might be having some doubts in that. You might not be. As you move forward to the binders and other tests, this course gets more interested and you will be getting more doubts on that sessions. So we'll be very much happy to discuss and gain the knowledge. For today's soil sessions, 2 hours, what we will be doing is there are three things that we will be majorly doing in these 2 hours of live session. I'll share my screen. You can also see on my PPT. Is the PPT visible to everyone? Thank you. So you can see here, these are the three main contents we will be doing in the 2 hours of live session every week. This can be modified also according to your needs and requests. Today we will be seeing how it goes. Based on that, we also will do the changes in that. The first thing is the summary. So whatever we have studied in the last week, we'll be summarizing in mostly 3 to 4 minutes, maximum 5 minutes. We'll not be spending much time on that because you could have thoroughly already watched all of that. A numerical solving session. So you might have been given with some of the assignments to submit. So in addition to the assignments, if there is any other numericals that we can solve. If you consider this first week of session, you might not be having more numericals to solve, and there will be some sessions like binder related contents. There also you might not be having much numericals, but wherever it is possible, wherever numericals are involved, we will be solving them, and these numericals will be apart from your assignment questions. So, for example, in this week you have assignment 1 to submit. This assignment 1, after your deadline is over, that is in your next live session, next Monday evening, we will also be discussing the answers and the descriptions of those assignment 1 also. In addition to that, as the participants are from wide variety, as I have already mentioned, there is a chance that some might be preparing for some competitive exams. Some might have been preparing for the semesters. So it requires to make a concentration on different varieties of problems. So let me see how we can go. For today's session, I have taken few of the gate questions also, and followed by we also will have a question and answer sessions. If you still wanted to, is there anything else that you all wanted to ask? You can unmute yourself and ask. Or is there any doubt on how these sessions would go? And if there are no doubts, then we'll be proceeding. And during this session, there rather than it's like some movie session, you can still take a pen and paper and a calculator mostly. You might need to solve some of the numericals that would be more interactive. And I won't be spending much time on the summary because you might have spent 5 hours of time already watching all those videos. But as far as the revision is concerned, we'll take this 2 to 3 minutes to go through what just have studied in the past week. If you could see in the lecture one, we have started with the introduction to soil as a highway material, where we have where SAR has given introduction to soil, why it is required in the pavement materials, followed by the particle size distribution in the lecture 2 and 3. Mainly, as far as the numericals are concerned, In addition to the Stokes law, how can we do the corrections to these hydrometer readings? In addition to that, how do we determine the percentage finer in the hydrometer, the sieve analysis in the hydrometers? All these related numericals mostly will be coming. Wait, someone has joined. So in addition to that, if you see the lecture 4 and 5, which is on the consistency limits and classification of soils, we have studied about all Atterberg limits and how to classify the soils based on that. In addition to that, the classification of soils as far as US classification and also IS classification, what is the difference? And also the ASTO classification. Based upon that, how can we classify the soils given the properties of the soils? These are the contents we have actually studied in the last week. So let me start with the basic numerical solving session. You can actually type your answers also in the chat box, or you can feel free to unmute yourself and tell. So I have given a question here. Let us say, which of the following soil is the alien soil? Yes, as Rajiv Das has mentioned, this is the residual soil he has mentioned. Is there any other answers from the participants? So there are two different types of soils you might be knowing. One will be the transported soils and one will be the residual soils. So when do we call a soil as residual soil? The residual soil is, for example, we have a set of boulders or bigger rocks at one place. So given the amount of time, a few parts of those aggregates will be transported to other place. For example, this transportation can be using the water. This transportation can be because of the wind. It can be through the medium of anything else. Those are actually called as transported soils. When all the metals have been transported, whatever has been left is actually called as residual soil. So here my question is, alien soil is which type of soil? So if we know the meaning of alien, then we'll understand. Is there any other answer from participants other than residual soils? And participants are asking for how to download this book. Uh, all these questions we'll discuss at the end. So other than this residual soil, is there any other answer from the participants? You can type in the chat box. If there are no. So you can see here, aeolian is a meaning that if any soil that is being transported based upon any other medium, those are aeolian soils. For example, based upon the wind. So if you could see sand, so when there is a bigger storms, what happens due to the heavier winds, sand will be traveling from one place to another. So here the medium is the sand. Those type of soils are called as aeolian soils. So aeolian soil is a type of transported soil. This is not a residual soil. Can somebody type the answer? Then which type of soil can be a residual soil? Either organic or inorganic. I'm giving the two options. Either organic soil is called as a residual soil or inorganic soil. Organic. So, for example, how does this organic soil usually comes? So, when we have a vegetation, let us say if we have the plants or any vegetable related waste material, when they are deposited at one place, they becomes the organic matter. They are decomposable. So they are the residual soils. They will not be transported from one place to another. Whereas these aeolian soils, and there are other types of soils, when the soil is transported based upon the river water, they are called as alluvial soils. If they are based upon the uh, glaciers, that means if the soil is transported using the snow, those are called as glacier soils. There are different types of transported soils which are mostly non-organic. So, for example, I am giving one of the soil here, lacustrine soil. Can anyone tell which type of soil do we actually call as lacustrine? That means what is a medium? When the soil is transported either using wind, water, or what? Yes, lake water. So if the medium is a lake water, that is actually called as lacustrine soil. So these are the soils that are deposited at the bottom of the lake. Alluvial, which we have already discussed. What could be the medium of this alluvial soil? Any answers from the participants? So when the soils are transported by the medium of water, we call them as alluvial soils. So you can actually remember, if you see in the first question, aeolian soil where the medium is the air or wind. Alluvial is the medium is the water. So which we already know. And the marine as the name. And if you see this question, which of the following are true? We'll discuss ABC individually, but I just wanted you to read and understand by yourself at the initial stages. The first one is, at shrinkage limit, the soil remains fully saturated. Is this true or not? At shrinkage limit, the soil remains fully saturated. If it is true, you can type the true. At shrinkage limit, okay, Krish is saying that it's false. Rajiv Das says it's false. Anybody else? Even if it is wrong also, no problem. Please try to answer your option. Madhusudan says it's true. Okay. So before saying whether it is true or false, when I say shrinkage limit is a particular water content. For example, beyond the shrinkage limit, even if you add water also, there will not be any change in the volume of the soil. Why? Because let us say there is a soil of 50 grams. I have added a particular amount of water to it. So I have added the water in such a way that I have filled all the air voids. So when I have filled all the air voids, the volume is completely filled. If I keep on adding water to it, its entire volume will be changing based upon the amount of water that has been added. If you start from the liquid limit, plastic limit, and the shrinkage limit, how are we determining in the laboratory? While determining the liquid limit, we add some extra water to the soil. So at that place, actually, each soil has more water content and it doesn't have any shear strength. It looks like a liquid. It looks like a water. Then what we do? We remove particular amount of water. Then what happens? Some soil becomes a little bit of dry. Then it comes from that liquid state to plastic state. Again, after that, we will remove particular amount of water. Now the soil comes into a state that is what called as shrinkage state. So this is the shrinkage state where all the voids are completely filled. They are fully saturated. So there is no space to add further water. So at shrinkage limit, usually the soil remains fully saturated. That is the only limit. So at shrinkage limit only, there will not be any change in the volume. Beyond shrinkage limit, if you add any further amount of water, the volume of soil is going to be increased, because the amount of water is being added to the existed volume. Initially, the volume is dry soil plus the air voids. Until you are filling the air voids with water, there will not be any change in the volume. Once if you fill all the voids with the water, whatever extra water you are going to add, that will be extra change in the volume. So shrinkage limit is the water limit where the soil remains fully saturated. So the option A is correct. I can still make you people unmuted. If somebody have any other doubts, you can still ask. And if we come to the option B, the shear strength of all soils at liquid is the same. This is actually related to the discussion which I have done just a minute before. Is it true or not? Usually, what is the shear strength of the soil at liquid limit? The value. What is the shear strength of the soil at liquid limit? Liquid limit is nothing but water content. When I add the water to the soil, it becomes like a slurry. So let us take, if you take a slurry mud water, what will be the shear strength of that mud water? When I say shear strength, if I apply a load on that slurry, it should be able to take that load. It cannot take, yes. Madhusudan, it's zero. So that slurry cannot take any shear strength. So at liquid limit, the shear strength is always zero for all the soils. So if you take any type of soil, the liquid limit will give the same shear strength. That is what the option D is telling. So this is true. When it comes to the option C, the shear strength of all soils at plastic limit is the same. Is it the same? At plastic limit, false. So plastic limit is, for example, you add particular amount of water content to the soil, you try to make a 3 mm thread and you try to roll that thread. When you are about to make a thread, you will see that there will be a slight cracks on the thread. So the water content at which usually those cracks have formed, that water content is usually we call as the plastic limit. That will be depending upon the type of soil. It will not be same for all other soils. But when you consider the shear strength, it will be same at liquid limits. That same is nothing but the zero. So first two are true. And this PPT will be shared to you. You can download it later also. So this now we are going to solve a problem. I have given you two types of clay. I have given you two types of clays here. If you see the clay A type of clay, I have given liquid limit as 44, plastic limit as 20. And if you take the clay B, liquid limit as 55, plastic limit as 35. What we wanted to find out now is, the first thing is larger settlement under identical loads. So I have taken the clay A and clay B at the same time. I am going to apply, let us say, 10 kilonewtons load on two clays. So the applied load is identical, same load. Which clay do you think is going to settle more? So in order to understand which clay will settle more, Which property of the soil will be we might need to determine? Any idea? Which property of the soil will be useful to understand whether that soil will undergo settlement or not? You have liquid limit and plastic limit. So using these two, so when we have done the soil classification, you could have seen a classification like low compressibility, intermediate compressibility, and high compressibility. If you take the unified soil classification, US classification, you have only low compressible soils and high compressible. How do we actually define a soil as compressible, non-compressible? It is based upon the liquid limit. For example, if the liquid limit is less than 35, we call it as low compressible. If it is more than 50, we call it as high compressible. If it is in between, we call it as intermediate compressible. This is according to the IS classification. So if the soil is more compressible, will it have the more settlement or not? So higher the compressibility, they will have more settlement. So using the compressibility property, we can tell whether the soil will undergo more settlement or not. So based by looking at the liquid limits, I wanted you to both look at these two soils. So you have liquid limit of 44 for clay A, liquid limit of 55 for clay B. So I wanted you to type in the chart box whether clay A is of low compressible or high compressible, whether clay B is of low compressible or high compressible according to the US classification system. Which is high compressible? You can type that whether clay A or clay B. Yes, Krish says it is clay B. So clay B is having high compressibility. If the compressibility is more, what can we say? It is undergoing large settlements. So we have finished the first part. And the second thing is which is more plastic. So how can we determine whether a soil is more plastic or not? Which property do you think will be more useful? As I told, liquid limit is useful for understanding the settlement. Do you think only plastic limit is enough to understand the plastic property or is there anything else? And this has been discussed in one of our videos also. What is that property which will be more useful to tell whether that soil is of having more plastic nature? Yes, Madhusudan, it is plasticity index. So you have liquid limit and plastic limit now. To calculate the plasticity index, which is liquid limit minus plastic limit. So please calculate the plasticity index for these two soils. So if you see for the A, the answer is B is in high compressible zone, so more settlement. And if you come to the plastic question, please calculate the IP. So if you calculate the plasticity index for A, it is 24. Which implies that that is more plastic. Classification, right? So according to the ASPEC classification, what is the group index? If the soil passing through 75 micron is 50%, you can note down these inputs. liquid limit is 40%, which is 0.2 into A plus 0.005 into AC plus 0.01 into BD. So here you all already know how to calculate the ABCD also. This is extremely easy. If you take A equal to F minus so F is the percentage of soil that is passing 75 micron. Here that is around 50%. So you can substitute F as 50% and calculate the A, B. And if you come to the C, here WL is nothing but liquid limit. So we already have the liquid limit as 40%. We can calculate the C also. And when it comes to the D, IP is nothing but the plasticity index. So plasticity index is nothing but liquid limit minus plastic limit. So we can substitute that also. So once you calculate A, B, C, D, you can also substitute them into the group index and you will get the group index value. What is the group index value? If anybody have calculated. Any answers? So it is a direct substitution. You can see here. If we calculate A, B, C, D, these will be the values. And if you substitute them, you will get group index value as around 6.5. And if we move forward, the sixth question will be the coefficient of curvature is 1.4. Coefficient of curvature is nothing but Cc, which is D30 square by D60 into D10. So this you will be seeing in the soil classification. So this Cc has been given as 1.4 and D30 is given as 3 mm. D10 is given as 0.6 mm. So based on the information of particle size distribution for use as subgrade, this soil will be classified as. So the information given is Cc is given, D30 is given, D10 is given. So based on this information, how can we classify the soil? First, if you see the options, all the options are like uniformly graded sand, very fine sand, well graded sand, or poorly graded sand. These are the options. So they are telling it is a sand, but you need to confirm whether that is well graded or uniformly graded or poorly graded or very fine. So what do we need to determine whether the soil is well graded or poorly graded? What is the criteria? You can also unmute and tell your answers. So in order to explain whether a soil is well graded or poorly graded, what is the criteria? Let us say using CU and CC, uniformity coefficient and coefficient of curvature. What is the criteria to tell whether a soil is well graded or poorly graded? Anyone? Okay. If the CC is between 1 to 3, and along with that there will be another condition, then we call it as well graded. As Krish mentioned, yeah, one of the criteria is CC should be 1 to 3. In addition to that, CU also should be greater than how much? For being a sand. If I want to call a soil as a sand, how much should be the value of Cu? Should it be greater than 4 or should it be greater than 6? Because we have two criteria. Yes, Cu greater than 4 is well graded gravel and Cu greater than 6 is well graded sand. In addition to the Cu value, Cc also should be in between 1 and 3. So now you already know Cc is already given in the question, which is 1.4, that is in between 1 and 3. So now you need Cu. If you want to calculate Cu, what is the formula? That is D60 by D10. But did we get the D60 here? No. So how can we calculate the D60 now? So we already know the formula for Cc. See, we need to determine the D60 now because we wanted to calculate the coefficient of uniformity. D60. This D60 you can calculate from the formula Cc. You know the formula for Cc, which is nothing but D30 square by D60 into D10. You already know what is D30. You already know what is D10. What is unknown here is the D60. So you will calculate the D60 and you will substitute the D60 here. You will get the Cu value. Now you can see that quotient of uniformity is more than 6 and also quotient of curvature is in between 1 and 3. So as we discussed, when the quotient of uniformity is more than 6 and quotient of curvature is in between 1 and 3, we call that type of soil as well graded sand. So in the similar way, we have another question. So till now, let me pause here and ask, are there any questions do you all wanted to ask till now? Or do you wanted, are you all able to follow? Any other doubts or do you want me to go slow? Okay. And is there any doubts till now? Okay. So if you take the seventh question, in a soil specimen, 70% of particles are passing through 4.75. So when I say 70% of particles are passing through 4.75 mm, how much will be retaining? So 70 is passing, so 30% will be retaining. And 40% of particles are passing through 75 micron. So its uniformity quotient is 8, coefficient of curvature is 2. As per IS classification, this soil is classified as. You can note down the input. 70% of particles are passing through 4.75. 40% are passing through 75 micron. So, and its uniformity coefficient is 8, Cu is 8, Cc is 2. So, as per IS classification, this soil is classified as. So, initially, if we want to classify the soil, now what do we need to calculate? Now you have Cu and you have Cc also. How do we proceed with this problem? Okay, Krish is saying Cu is greater than 4. It is actually 8, so it is actually greater than 4 and also greater than 6 also. Anything else? So you can see here, for example, they have given there is a 4.75 sieve, 70% is passing, and there is another sieve which is 75 micron sieve, so 40% is passing. So first I have to confirm whether my type of soil is gravel or sand. So when do we call a soil as gravel? When do we call a soil as sand? Anyone? Krish is saying so it will be sand. We cannot directly come to that conclusion because it can be sand or it can be gravel for the moment. Based upon Cu, because Cu greater than 4 it is gravel, Cu greater than 6 it is sand. So it is satisfying both of them. So we cannot directly tell it is sand. So in addition to the Cu and Cc, yes, 70% of soil is passing through 4.75 C. So let us answer one question. 4.75 sieve, is it a representation of gravel or sand? Because in the soil classification, if sand, okay, then what is a 75 micron sieve? So in the soil classification, I have 75 micron. So we can do grain size analysis till 75 micron sieve. Below that we cannot do because you know the problem. Below 75 micron, it's difficult to sieve using regular sieves. There will be, so we will be going for the hydrometer analysis. So any soil size that is greater than 75 micron is a kind of coarse grained soil. So if I take the 4.75 sieve, if the soil amount is more than 50% is retained on 4.75, we call that as gravel. If more than 50% is retained on 75 micron, that we call as sand. So based upon these two criteria, first we have to determine whether the given soil is sand or gravel. Okay. So you can see here the given information is 70% is passing 4.75, 40% is passing 0.075 mm. Now we need to understand how much is retaining. So if I know the percentage retained on 75 micron, if the percentage retained on 75 micron is more than 50%, then I can directly say that whatever the soil is sand. If the percentage retained on 4.75 is more than 50%, then I can directly say it is gravel. So here 40% is passing means 60% is retained. So if the 60% is retained, 60% is nothing but more than 50%. So it is more than 50%. So the kind of sand soil is sand, and it is more than 50%. In addition to that, you people have already mentioned that Cu is greater than 6 and Cc is in between 1 to 3, which implies that is a well graded. So this is a well-graded sand. How do we represent that? SW. So whatever we write in the later stage, that is W, we have to pronounce in the starting. Well-graded sand. So let us do one match the following question. So here I have given four types of soil sizes. A is less than 0.02 mm. B is 0.075 to 0.002 mm. C is 80 mm to 4.75. D is 4.75 mm to 0.075 mm. So when I say 80 mm to 4.75 mm, the soil is passing the 80 mm sieve, but it is less than 0.02 mm. What do you call that type of soil? Do you call it as gravel or sand, cobble, silt or clay? If the size is less than 0.002 mm, what do you call? Yes, it is clay. And if the size is in between 0.075 to 0.002, what do we call that type of soil as? Here, what does it mean? Entire soil is passing through 75 micron sieve. So it can be either silt or clay. You already know that clay is when the size is less than 0.002. So definitely it will be silt, correct. And if you see the C, it is 80 mm to 4.75. So what is this we call? If the material is retained on 4.75, what do we call that? Any other answers? Gravel, yes. So cobble is when the size is more than 80 mm. When the material is retained on 4.75, we call it as gravel. And anything that is retained on 0.075, we call it as sand. So the answer will be 5412. If you want to look, you can look at it once. Okay. If we move further, there is a soil that contains 40% of gravel. So I have discussed that size related question till now because by now you might be having this information with you. Any material that is retained on 4.75 is gravel. Any material that is retained on 75 micron or 0.075 mm is sand. Any material that is passing the 75 micron is silt. You please note down it or remember 4.75 sieve is called gravel sieve, 0.075 sieve is called as sand sieve. Anything that is passing through 0.075 is called as silt, and anything below 0.002 is called as clay. Because if you see the next problem, they will not mention what is the size of gravel, sand or silt. For example, if you see here in the ninth question, a soil mass contains 40% of gravel. If somebody says 40% of gravel means, so you have 100%, let us say 100 kgs of total soil. In that 40 kgs of soil is retained on gravel sieve. What is the gravel sieve? 4.75. So 40% is retained on 4.75. And it continues with 50% sand. When I say 50%, 50% of material is retained on 75 micron sieve and 10% of silt. When I say 10 percentage of silt, 10 percentage of material is passing through 75 micron. Is this clear to everyone? Any doubt? If you just remember the sieve size for gravel, which is 4.75, for sand, which is 75 micron, water passing through 75 micron is the silt. So if you remember these three, we will be able to solve the upcoming questions. Okay, if there is no problem, we'll proceed. So if this is the case, this is the input given, what is the type of soil we can classify it as? And also calculate the Cu value. Here actually you don't need the sieve size requirement here to solve this question. One thing you have to understand is, let us say if you say SM, that means I am typing, let us say in chat box SM. What does that mean? How do you pronounce this classification as? You can reply there. SM means which type of soil it is? What is the full form of SM or GC? For example, SW. We have already discussed SW. What is SW? Anyone can answer any of these three. How do you call SM, GC, and SW? Full form? Anyone? SW is well graded sand. So, what do we call SM? M symbol is a representation of which type of soil? C is clay, M is silt. So, if M is silt, what do we call SM? M is silt, S is sand. So, how do we pronounce it as? So, it is actually silty sand. So, the symbol looks SM, but you have to write starting from later symbol. Let us say SM, S is the sand, M is the silt. But we have to call it as silty sand. What does that represent is, the type of soil which we have is a sand, but here in this sand, the major portion of the soil is silt. So when I say silty sand, so when I say silty sand, that means in the